Hey everybody. So I'm going to try this format this time and see if this maybe makes it a little bit better. But I do want to start off the video saying hello and I miss you guys and um, I do not prefer this way of teaching. All of this technology is driving me insane. So if it's driving you insane as well, at least we are in this together. But I'm going to go ahead and get started with this week's lesson. So there is just going to be one lesson this week because there's, as you can see, 4 different components with what we're doing. And so make sure that you're paying attention to the assignments that go along with it. If you are in an advanced class, you are going to have a couple extra IXL skills that you need to do. And then because this is only one lesson, there are only so many IXL skills. So some of them you're going to have an extra assignment this week is what I'm trying to say, general and advanced. Okay, so please make sure you're paying attention to that assignment outline. And then if you have any questions, even if it's just for clarification, please, please, please reach out. I'd rather you do so sooner rather than later. And you can do so through email, through Teams chat. Remind if you've got that capability. I know some of you aren't able to message me on it with the age restriction, but your parents can message me through it, or with that distance learning plan I sent out, that cell phone number that's up in the top, you can text me on that number, okay? That's why it's there. So however you need to reach out to me, I am here for you guys. But we're going to get started. So we're continuing with our data unit. And so with a set of data, there are certain measures you can find. So basically, what's one number or what's kind of just almost a summary of this set of data, opposed to having to look at the whole list of numbers or look at a line plot or something like that. So for our data measures, we've got 4 that we're going to talk about today. There's more we'll get to later, but mean, median, mode, and range. So those are the 4 that we're going to talk about today. So the first thing I want to point out is that 2 of these are considered measures, that is a C, of center. So when you think about center, you kind of think about where everything else is spread around it. And so that's basically what these 2 numbers are going to do, is they are going to be a single value used to describe a set of numeric data. So they are considered a typical value from the data set. So like a summary, like I said, we're going to find these measures of center. Both of them will be just one value that if somebody said, hey, about how much blah, 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 you could give them this one value. So the first one we're going to talk about is the mean, which is also known as the average. And so I know a lot of you probably already know that word average. The mathematical term we're going to use is mean. And so the mean is, or with the average, thinking about, again, if somebody said on average, what kind of blah, 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 you're not going to give them the smallest one. You're not going to give them the highest one. Average kind of means if all of these data values were put together and then spread back out evenly, what would everybody have gotten? So if you're thinking about like a test, in a class, you know, if the lowest was a 50, the highest was a 90. What if we took all the points that everybody got and spread it back out so that everybody got the same grade? What would that grade be? So it's that kind of concept. So when I say put together, I mean we're going to find the sum, which means we're going to add all of our data values, and then we're going to divide that sum by the number of values in the data set. So like if 10 people take a test, we take all their points, and then we're going to split them all back out evenly through the 10 people. So to kind of visualize that, here's an example. Tammy surveyed 5 friends to find out how many siblings they have. So Amy has 2, Ben has 3, Cal has 1, Don has 1, and Eva has 3. So I kind of drew like a little counter situation here to where we can visually see what we've got. And I hope this kind of helps see how we're going to, you know, move some points from one side to the other to evenly distribute these values. So we're going to evenly spread them out. So this, like we talked about last week, kind of like the distributive property, yeah? So if we're looking at this visual, we can see that these 2 both have less than the rest, and then these 2 both have more. So maybe if I move those there, let's see what that looks like. So then Amy would have 2, Ben would have 2, Cal would now have 2, Dawn would now have 2, and then Eva would have 2. And so now they all have the same. We've taken those values and we've distributed them back out evenly. So our mean is going to be 2. Obviously, I don't expect you to draw counters for everything, especially when these numbers start getting bigger. This method is going to be impossible, but I do hope it kind of shows you, again, that visual. So let's check our work mathematically. We said we're going to find the sum, so we're going to add them all up. So if we've got 2 plus 3 plus 1 plus 1 plus 3. And then there are 1, 2, 3, 4, 5 values. So that's how many, that's what we're going to divide that sum back out by. Let's see, 2 plus 3 is 5, 6, 7, 8, 9, 10. And sure enough, 10 divided by 5 is 2. So let's do another example. Spencer surveyed 8 friends to find out how many pets they have. And so these are going to be his 8 friends' answers. So then again, just mathematically, let's add those up together. So we'll do 3 plus 5 plus 2 plus 4 plus 1 plus 3 plus 1 plus 1. It said 8 friends. Let's make sure we have all 8 values. 1, 2, 3, 4, 5, 6, 7, 8. Good. Which means we're going to divide that by 8. With the sum, so the more numbers you get, depending on how many numbers are in your data set, what place value they're in, something I like to do is kind of group them up and see if I can make maybe sets of 5 or 10, just because we all know it's a little bit easier to count by. So I'm noticing 3 plus 5 is 8, plus 2 is 10. So I'm just going to kind of group these up here, 10. And then 4 plus 1 is 5. And then 3 plus 1 plus 1 is also 5. And so that just kind of helps me add it all up. And then we know that 10 plus 5 plus 5 is going to be 20. Now, 20 divided by 8, that's not going to be a whole number. But that's okay. If we're talking about the mean, we're talking about the average, the number doesn't always have to be something that was in the data set. So when we add these all up and split them out back evenly, it's honestly going to be kind of rare for the mean to be one of the numbers that was in the data set just by the nature of adding and then dividing. Further, I know we're talking about pets here, so we're not going to have half of a dog, but we're just talking about an average. So we're talking about a numerical value, and it's okay if we say 2.5 when we're talking about pets. I say 2.5 because we know that 20 over 8 is 2 and 4/8. Yes, which we know simplifies to be 2.5. So you can use fractions if you want. You could also do long division. I'll do that over here. 20 divided by 8. 8 does not go into 2. It goes into 22 times. 2 times 8 is 16. If we subtract, 10 minus 6 is 4. We know now that we can add a decimal, bring that up, add a 0, bring that down. 20 is the same as 20.0, 20 and 0 tenths, excuse me. So then 8 goes into 40 exactly 5 times, which is 40, and we are done. So 2.5, or we could say 2.5, same value. Yeah? All right. So the next measure of center we're going to talk about, so we're still on measures of center, is going to be called the median. And so for the median, I kind of like to think about the median in the, oh, there we go. Sorry about that. I kind of like to think about the median in the set, like in the road. So if you're driving and there's, or riding in the car, I guess none of you are driving, there is the median of like grass and stuff in the center of the road. And it's called the median because it's literally in the middle of the lanes, right? The lanes are on either side of it. So that's kind of what we're going to do with the median of our data set, is we're going to find the value that's directly in the middle. Now, if we, let me put that there, the middle of an ordered data set. So median is literally the middle. However, when we think about finding the middle, if the numbers are just in any random list, that's not really going to do much for us, because then any number could be there. That's not really going to be typical of what's in the data set. But if we put them in order from least to greatest, then like we said earlier, we're finding that typical value. You know, we don't want to give somebody the least. We don't want to give them the greatest. We want to give them kind of what everything is around. And so the median is going to be physically, literally that. what is the direct middle of my data if I put it in order from least to greatest. So step 1 is going to be to list the values from least to greatest. And then after that, this step, you can kind of work through this one how you see fit, what makes the most sense to you. But I suggest that we cross out one value at a time from each side of the data. So once we've got that long list, we're literally just going to go cut, 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 one at a time from each side until we find that middle. So let's do an example. A coach records distances some cross-country members ran last week. So here's my little clipboard from my coach, and these are all of the distances that the cross-country members ran. So if we put those in order from least to greatest, I'm going to give myself a little check as I write them down just so I don't repeat any or miss any values. When you're doing median, you might miss a value. You might have to rewrite your list or squeeze something else in there. So that's okay. Just always make sure you're double checking. So let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Perfect. So there's 7 values. I've got 7 values in my list, least to greatest. Let's double check that. 3, 4, 5, 7, 8, 10, 10. Perfect. So with our values from least to greatest, that was our step 1. And step 2, we're literally just going to cross out one at a time. So one of the least, and then the greatest. Now the new least, the new greatest. And we're just going to keep doing that until we are left with our one value in the center. So 7 miles is the median number of miles ran by this cross-country team, which again is pretty average, pretty typical, right? Makes sense. Some ran less, some ran more. Let's do another example. Charlotte recorded the number of minutes she spent on her phone one day. So here's what we've got down here. She's got a lot more self-control than I do. So this is a longer list, so putting them in order from least to greatest is going to take a little bit more time, be a little bit more tedious. Remember that word. But we can do it. It's easy. So 1, there's a 2, let's see, 4, so another 4, nope, 5, and 6, good, 7, there's 2 8s, 9, and 12. Good. All right, so that's step 1. Step 2, let's cross them out. So 1, 2, 1, 2, 1, 2, 1, 2. Uh-oh. So there's going to be 2 values in my center now, and that's because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have an even number of data values. So when you have an odd number, you know, we cross them out, and then we're going to have 1 left in the center. But when we have an even number, we're going to have 2 equal halves, right? That's kind of what makes the number even. And so we're not just going to pick one. We're not just going to say, okay, it's 6 or 7, right? A measured center is one single value. So what we're actually going to do is we're going to take both of these and we're going to find the mean of the 2 numbers. So we're going to take those 2 numbers and kind of split them out evenly and find their center, find their average. So the median number of minutes, we're going to find the mean of 6 and 7, which means we got to add them up. Divide by 2 because it's 2 numbers. 6 plus 7 is, I didn't write this down, but that's going to be 13 over 2. And we know that 13 over 2, it's an odd number, so right in between we're going to have 6 and a half. So the median can also be a number that's not in the data set if you've got an even number of data values. But 6 and a half is the best way to say 6 or 7, right? It's right in the center. And again, this is a good value to represent this data set. So now we've learned 2 separate measures of center, the median and the mean. And what's going to happen, though, is if somebody says, well, what's a typical value in this data set, which one do you say, right? Do you use the mean? Do you use the median? And sometimes it's going to depend. So when we compare the mean and the median, since the mean and median are both, like we said, measures of center, they might be equal or very close to each other. And both describe or represent the data well. So it really just depends sometimes. especially if, you know, the mean is 6.5 and the median 7. Those are both pretty good, pretty representative of the data set, so it wouldn't really matter there. But say the mean was 6 and the median was 12. That's a big difference, right? So let's do a couple examples to help us determine which one will be better and why we can make that decision. So tree heights in a park in meters: 7, 11, 9, 7, 6, and 8. So for the mean, like we said, we're going to add those all up. So 7 plus 11, 9 plus 7, 6 plus 8. Again, like I said, I kind of like to group together where I can to make it a little bit easier to add. So I'm noticing that 11 and 9 make 20. 7 and 7 make 14, plus 6 make another 20, yeah? And then 8, so we're going to have 48 here. And then we've got 1, 2, 3, 4, 5, 6 values, so 48 divided by 6 is 8. Good job. So our mean here is going to be 8. For our median, we need to put them in order from least to greatest. So we've got a 6, 2 7s, 6, 2 7, 8, 9, 11. Check them off, make sure we have them all. And now if we cross those out, left, right, oh, we got 2 in the center again. So 7 and 8, and we should, I hope, kind of already recognize from the last one that we'll do 7 plus 8 divided by 2, because there's 2 values. We're finding the mean of 7 and 8. 7 plus 8 is 15 divided by 2, which we should know is 7.5. So this one's kind of like the example I was using when I was explaining to begin with. 7.5 and 8 are pretty close to each other. Given all of these values, I would say either of them represent the data pretty well, because they're both a little bit more than some, a little bit less than some. So both of them, yeah, 8 and 7.5 are close. So they both describe the data well. Not always going to be the case. Hope you kind of saw that coming with what we've already talked about. So another example, the points scored by a football team. Let's see, there we go. 7, 20, 24, 17, 28, and 24. So for the mean, we're going to add these values up. So 7 plus 20 plus 24 plus 17 plus 28 plus 24. I'm going to come and do my addition over here just so I can keep my notes a little bit cleaner. I'm going to add all my 20s together. Personally, I just see that making the most sense for me. So 4 plus 4 is 8, plus 8 is 16. 2, 4, 6, 7. And then that's ending in a 6. So let me check off the ones that I did so we can keep track. Okay. I've noticed 7 and 17. That's going to give me something that ends in a 4. So I'm going to add those here because then I'll have a nice clean 0 number. So 14 plus 6 is going to be 20. 7, 8, 9, 10. And then all we have left is 20. So we know 100 plus 20 is 120. And we've got 1, 2, 3, 4, 5, 6 values. So 120 divided by 6. We know that 12 divided by 6 is 2. So 120 divided by 6 is going to be 20. It's going to be our mean. So pretty good. Sounds about right-ish, I would say. For as far as the data set goes, we know that that answer is right. For the median, let's put these in order from least to greatest. 7, and then we've got something in the teens. Now we can look at our 20s, 2 24s, and 28. Good to go. So least greatest, got 2 in the center again. So 20 plus 24, 44. We're finding the mean of 2 numbers, so we're going to divide by 2, and that's going to give us 22. Which one do you think describes the data best? All right, it's actually going to be the median here. So I know 22 and 20 are still pretty close, but I could have told you from the start that the median was going to describe this data set better because we've got what we talked about last week, an outlier. Think about it. This is in the high teens, We got 20s, don't even get to 30, so everything's really around 20. A little bit more than it, though, right? What happened? Got a little dark. Oh, sorry about that, technical difficulties. And so a little bit more than 20, right? Like there's only one data value less than 20, one is 20, and then we've got 3 that are more than 20. So this 7, because of the nature of how you find the mean, because this 7 is so much lower than all the rest of my data values, it's going to bring that mean down, right? Think about a test grade. If, say one person gets a 60 and then everybody else is getting like a high 70 or 80, that mean is going to be in the 70s, though, in the low 70s, which doesn't really make sense. If a lot of people got 80s and 70s and there's only one person that got a 60, that lower outlier is going to bring that mean down. Or vice versa, maybe the 7 wasn't here, maybe there was like a 40 something over here. That would bring that mean up, which would be a little bit more than what they're getting. So this 7, if you're looking at these scores, you can tell it's kind of not typical for them, right? It's a lot lower than the rest. We don't want to use it to describe the whole data set. So we want the median because it's going to be a little bit higher and a little bit more representative of all of them. So the outlier, that's the key here that we're looking for, brings the mean too low. I don't think that makes sense as far as a language arts teacher. So if any language arts teachers are watching this, please do not come for me. But the outlier is going to decrease our mean, so our median is going to be best. All right, we've got 2 more data measures to go through. These ones are pretty quick, they're pretty simple, so I'll try to make this as quick as I can. The first one we're going to talk about is, well, the third one, but the next one is a mode. So the mode is the data value that appears the most in a data set. Oh my goodness. There we go. So I like to think of that they sound alike, right? The mode is the most. And we kind of already talked about this one with our dot plots as far as the peak goes. So I'm going to put that there too. Which one's happening more than all the other ones? So a data set, though, will not always have a mode, right? You can have a data set where no values repeat, or you could have more than one mode. Because we're literally just looking for the data value that happens more often than the rest. So got 3 examples here to kind of show all of those options. So we've got our data set. We're going to just look through. It's literally this easy to look through and see which one's happening the most. So maybe if you want to make a line plot, that might be helpful for some of you. But 3, 5, 4, 2, 3. There's another 3. So I know that one's repeating. 5. Okay, so there's 2 5s. Square. And another 3. All right, so there's 2 5s, but there's 3 3s. So we know that 3 times is more than 2 times. So we've got one mode here, and it's going to be 3. For number 2, 6, 8, 3, 9, 8. All right, there's 2 8s. 6, so there's another 6. 4. All right, so there's 2 8s and 2 6s. So our mode is going to be 6. And let me draw another box. We've got 2 modes this time, 6 and 8. Okay, and then for the last one, 7, 10, 8, 15, 3, 9, and 5. None of them repeat, so none. There just is no mode, and that's okay. So again, the mode isn't still a typical value of the data set, but definitely not always going to be as representative as the mean and the median. I think it just kind of depends on the data set you're talking about, where the numbers are coming from. For instance, maybe if I was asking about the ages in a single 6th grade math class, the mode would probably be a good one, though it would probably end up being the same as the mean or the median, right? You're all around the same age. Whereas if I was looking for the age in like a grocery store, right? I took a random sample there. The mode might not be the best just because they're going to all differ so much that just because maybe there's 2 30-year-olds, that doesn't mean that that's necessarily what's most common. So using that, actually talking about typical age of a grocery store, that's kind of hard, right? Because literally everybody goes to the grocery store. So saying, oh, well, the typical age, even if, the mean was 30, well, that's kind of hard, right? Because what about all the babies and what about the older people? So something else that we can use to describe a set of data is a measure of spread. right? Maybe if we're talking about age range of a grocery store, we don't want to know one number of how, there's not really a typical age there, but we could say, well, the youngest customer we get is this old, and the oldest customer we get is this old, and look at that age range. And so that's the measure of spread we're going to talk about. And I know you guys have heard that word before, range, because we're talking about the spread of the data set. How much do those values differ? How far apart are they? And it is going to be that single number. So for range, I always like to bring up the point that a lot of you are in chorus, and so or play an instrument. I don't know if this applies to instruments, but I know it does for chorus. Your vocal range, right? How low can you go and how high can you go? And so that's exactly what we're going to talk about here, but with numbers. So the difference, which we know means what operation? Subtract between the least and greatest values in a data set. So we're literally just going to take our data set, find the smallest number, find the greatest number, subtract them, and that's going to tell us our range. So the following are the ages of students in a dance class. So I went ahead and put these in order from least to greatest for us just to save some time. But the least is 12, the greatest is 16. So our age range is 4 years. Everybody's within 4 years of each other. And that's helpful. That's super helpful information. Another example, the following are the number of goals a soccer player made. So again, went ahead and put those in order from least to greatest. So 0 is the least, 4 is the greatest, 4 minus 0. This range is also going to be 4. And I feel like in soccer, maybe that's a big range of number of goals that you can make in a game. I don't really know soccer that well, but again, this could be helpful, right? If somebody's range is like 10, that means they're kind of inconsistent, right? You never really know how, are they going to score a lot of goals or are they not? Whereas if their range is 4, it's a lot smaller. You can kind of be a little bit more on par. Well, we know if anything, they're not going to score more than 4 with this data set, but they're all going to be a lot closer with each other, so you can make a little bit more of an educated guess at how many goals they might make or how old somebody in the dance class is going to be, the smaller their range is. So that's it for our notes for today. I hope that was helpful. Again, if you have any questions at all, please, please, please reach out. I would rather you ask ahead of time and just be sure, because I know this is not the same as me teaching in the classroom. So I want to make sure you're still getting the best lesson you possibly can. All right. Thanks, guys.